Okay, we're doing number 5 on page 95. Whoops, let's get the color better here. Page 95, question number 5. And the question is, what is the limit as x approaches 0 of 1 over 2 plus x minus 1/2 all over x? Okay, well, first off, let's just try plugging in x equals 0. If we put in x equals 0, we get 1 over 2 plus 0 minus 1/2 all over 0. And so that's 2 plus 0, that's 2. So 1 over 2, 1/2 minus 1/2 is 0 divided by 0. Not helpful. This is an indeterminate form. Meaning we can't determine what the limit is based on just plugging the number in. If this had turned out to be 0 divided by 3, okay, we can do that. 0 divided by 3 is 0. If it had turned out to be 3 divided by 0, we could do that too. We could say that limit does not exist. But if it's a 0 on the top and a 0 on the bottom, we can't say one way or the other what's happening. So we got to do some other stuff. Okay, there's going to be an easy way to do this one and a hard way to do it. I'm going to do the hard way first so that we can see the benefit of the easy way. So this is the hard way. The hard way is to say I'm going to do my algebra to simplify this fraction. Okay, so we'll take this left-hand fraction and we'll multiply it on the top and the bottom by 2. And this right-hand fraction will multiply on the top and bottom by 2 plus x. That way I've got a common denominator of 2 times 2 plus x. And so that becomes 2 over 2 times the quantity 2 plus x minus 2 plus x over that same denominator. And then don't forget this whole thing's all over x. We'll deal with that x on the bottom at the end. Alright, we can subtract these two fractions. The denominator stays the same, 2 plus x. On the top, it's 2 minus 2, so those cancel. And it's minus a positive x. Don't forget that this minus sign has to distribute through. So it's minus 2 and minus x. So we have negative x all over x. Negative x over 2 plus x, all over x. Okay, now we can get rid of this x on the bottom by saying this is negative x over the denominator times 1 over x. That's to deal with this dividing by x. And I'm sure you are already a step ahead of me and see that that x and this x cancel each other out. And so we have negative 1 over 2 times 2 plus x. As x approaches 0, this becomes 1 over 4 with that minus sign out front, negative 1/4. There's our answer, negative 1/4. Well, that was the hard way to do it. Let's do it the easy way. So let's pop up a new slide here. And I'm just going to rewrite the problem real fast. The limit as x approaches 0 of 1 over 2 plus x minus 1/2 all over x. Now, if you haven't already figured out what the trick is here, let's recognize that x is just a letter, and it could be any letter we wanted. So if I wanted to write it as an h instead of an x, I haven't changed the problem. I've just changed what letter I'm using. But now, it looks pretty familiar to us. It's a function that has 2 plus h minus a function that has just a 2 all over h. In other words, this is the limit as h approaches 0 of f of 2 plus h minus f of 2 all over, all over, not 2, that was a typo, all over h. If f is 1 over x. If f is 1 over x, then 1 over 2 plus h, boom. 1 over 2, boom. So for that choice of f of x, this limit is the same as this limit, but that thing right there should look really familiar to us. That's the definition of f prime. That's the definition of the derivative evaluated at x equals 2. And so all we got to do is the derivative of 1 over x. Well, that means we're taking the derivative of x to the negative 1, which, as you know, is negative 1 times x to the negative 2. So that's negative 1 over x squared, evaluated at x equals 2. Negative 1 over 2 squared, negative 1 over 4, negative 1/4. So you don't have to pull all those algebra tricks if you recognize that this limit is really just the derivative of 1 over x evaluated at x equals 2. Alright, that's that.